Hello everyone, welcome to Code is Good. In this video, we will look into how to handle collisions in hash table. In the previous video, we had seen that how a hash table works and how a collision affects its quality. So in this video, we'll look into a method called linear probing. Before going to linear probing, we should understand what a collision is. A collision is that when multiple items claim an index in the hash table, what happens in a hash table that we provide a key to a hash function. And this hash function, it gives an integer as an output, which is the index of the item in the hash table. Usually this hash table is a array based. So this index will be the index at which your actual data gets saved. And if multiple data they claim to be coming at the same index, then in that case this scenario is called a collision. There are multiple ways to handle collision. One is if we are getting collisions very often, then we need to alter our hash function. If hash function is good, then we can move this data, the multiple data coming into different indexes in the hash table. So one such way is called open addressing, which says that if in an array, if at index I, if something is there, then you can place the other item which claims to be coming at I at some other index. And one type of open addressing is called linear probing. What it does that it iterates your array in a linear way. Suppose if I have an array of index 0, 1, 2, 3, 4, 5, and I have two objects over here. The first index, it gets saved at index 4. The 7 index, the second item, this also gets hashed to 4 index. But since this is already occupied by, suppose this is A and this is B. So this is already occupied by B, then it will linear probing. It tells that go on to the next index and see if it is vacant, then you place the item over there. So although this B has got hash index of 4, it will get saved at 5. Another example, if we see that suppose if C is there and its hash function calculates its hash index to 5, then in that case it will tell me to go back to the initial of the array, and over here you save C. So this is how a linear probing algorithm works. Let's go into our IDE and try linear probing to the hash function and the hash table that we had implemented in the previous video. Over here, we have an employee class. It's same as the previous one, where 3 fields are there: ID, first name and last name, the getters and the toString. And over here, there's a test class which has few employees. And here also we'll use the same algorithm, the same hash function, which will take the last name and save the actual employee over there. Here, the last 3 I have taken, which will provide the collision. And this also needs to be saved. So we will look into our code that how we will handle this. Okay, so we'll implement put and then get one after the other. So over here in this class, we have got hash table, which is an array, and we are initializing it with 5. The reason I've taken 5 so that we can test the full occupancy of the hash table along with collision. Then we have got an occupied index utility method and hash function. This is same as the previous video. So the occupied index, it will tell me that whether for the given index an item is already present over there or not. Okay, so let's start with our put method. In the put, we will take a key and a value as employee, Okay, so let's first get the hash index. Okay, this hash index is given by the hash function, which takes our key. Okay, in our current scenario, we are handling collision. So like last time, whenever a collision has happened, we ignored that item to be inserted into the hash table. But in this case, we got to handle that situation. And whenever a collision has happened on this index, then we need to handle it. Okay. So what we will do, that we will start to check that if an item is already present over there or not. Okay. So when we were doing the explanation of this linear probing, we saw that we need to keep a counter of the index from the hashed index that got from the hash function. So for that, let's name this variable as stop index, which will start from 0. So what basically this will do, that is, this will tell me that whether we have iterated all the indexes in this hash table. And if it has iterated all, that means we are done with the hash table iteration, and we did not find any vacant index in the hash table. Okay, so let's get back to our algorithm and we'll check that if we have this index occupied or not. Index, hashed index. Okay, so if it is occupied, then we need to handle it. So handle the collision. Okay, so firstly, let us handle some boundary conditions, like if the item has to be inserted at the last element or last index of the hash table, and that is occupied. So we got to rotate our hash index to 0th index of hash table. So for that, what we will do, we'll provide hash index to 0. Sorry, we got to write a if over here. If the hash index that's equals to the hash table dot length -1. This will -1 because we will get the last index of the hash table. So then we'll do hash index is equals to 0. Okay. Then we'll iterate a condition. Okay. Again for checking if this index has been occupied or not. This has to go recursively. So we'll check if occupied hash index, if this is again occupied, then we'll try a while loop over here, and in this one we'll rotate and check that any of the index that is vacant or not. So we'll check that if occupied index of hash index that's vacant or not, and the stop index that should be less than our hash table length. Okay, and it will keep on trying till it finds, this is the condition that will keep on trying till it finds a vacant index in the hash table. Okay, and if it does not find, then we got to increment the hash index and the stop index. Okay, if, and then we'll check, we got to have a break condition also over here, that if we have iterated, suppose if we have iterated the entire hash table and we did not find the vacant index. So that will be given by our stop index. And if it is equals to our hash table dot length, that means we have iterated throughout the hash table, and then we'll break out of the loop. Okay, so and if our hash index that's equals to our hash table dot length, then we got to rotate the hash index. Suppose it is a scenario where the last index will go to the first index. Okay, so hash index will be again moved to 0. I understand that these codes, they are repetitive because we have a while loop to cover. That's a reason for that. Okay, so once we have got all of these conditions done, so the hash index, it will contain the index at which we have to do the insertion. Okay, so we'll come out of the if condition, and then we'll check if the stop index is equals to the hash table dot length. Okay, then we will say that we cannot insert and the hash table is full. Okay, else we will put the item in the hash table. Okay, hash index. Hash index equals employee. Okay, so this is our implementation for the put of the element in the uh, hash table. So we'll come back over here in a test class, and let's run till the addition of all these items. Okay, let's see what is the result. As you can see that the size of the hash table was 5, and we are inserting 8 items over here, so 3 should return in full, and only the previous 5 should be inserted into the hash table. When we are printing the hash table, then we see that the first 5 items has got inserted to the hash table. Okay, so now let's go ahead and implement our get. Okay, get, in our last video we had implemented such that we'll calculate the hash index, we'll calculate the hash index and get it directly from the hash table. But in this case, if we try to do it, then it will turn out very oblivious that in case of collision, we are doing a linear probing, so that will go for a toss. So we got to handle the get in a smarter way this time. Okay, if you want to see the how for simple hashing we had implemented get, then I will recommend you to please see the previous part of this video. Okay, so firstly, we'll be very positive and think that we will get our item from the index that we have hashed. Okay, so this will be given by the hash function. It will take the key and give us the key. So then we'll check if the hash table for the given hash index. Okay, okay, one more thing, like when we are doing the get this time, then it's very difficult to calculate or to get the uh, or to find from the index that which item is our key, because we are calculating the hash based on the size of the last name. So in this case, we got to alter something in our hash table. In this case, we will use a new class, we'll introduce a new class stored employee, which will have a key and an employee. And here's the constructor for that. So what it will do basically, that it will take the raw key of the data that we want to save, and this is the data. Okay, so for that we got to alter our implementation, and this will become stored employee. Okay, and this will become hash table. We'll rename this to stored 5, we'll initialize it to that, and over here we will save the new stored employee. The constructor takes your key, the raw key, and the employee. Okay, and this will get saved at the index. The stored employee will get saved this time. Okay, so when we will get the item, firstly we'll get the hash index, that what is the hash index from where we must start our traverse to find our item for the given key. Okay, so this time we'll check the index as well as the key value. Okay, that's why we'll do a hash table over here for the given hash index, and we'll take its key. Okay, and we'll check if this key is equals to the key that has come as part of input. Okay, if it's the same, then we'll simply return the hash table, hash index, and its employee. Okay, if we do not find, that means a collision is there. Okay, so in case of collision, like our put method will start with a stop index, which will tell me that with whether we have iterated or traversed the entire hash table. Okay, so it will be initialized with 0. Okay, and then we'll check in a while loop that if the hash table for the given hash index dot key, I mean, what I'm trying to say, that it does not match, that is the condition in which we will do the continuous traversing of the hash table. Dot equals key. Okay, here also we will break the loop if all the indices are traversed. So it will come as stop index hash table dot length, and if such a case happens, then we'll break out of the loop. Okay, and post that if the end of the hash table comes, then we need to rotate it back to the 0th index. Okay, so this is the condition, that if hash index that's equals to our hash table dot length -1, this is the last index of the hash table, if it comes into that, then we'll make it hash index equals to 0. Okay, if none of these scenario matches, then we'll increment hash index and stop index. Okay, so together will help us in our iteration. Okay, so what this will do, this set of code, it will help me get the hash index, that at what index my key is present. Under that condition, this while loop will break. Okay, then we'll come to our final work and we'll check that if key is found in the hash table for the given hash index or not. Okay, so this hash table for the given hash index dot key dot equals, this is the input key that has come. So if it is equals to that, then we got to return hash table at the hash index and the employee at that position. Okay, if it is not found, then we'll return it as null. Okay, so let's go into our test method and see what we are trying to get. Firstly, let's try to get Gilmer. Okay, and if we run our code, then post printing the array. Okay, didn't we include? Okay, so for Gilmer, here is the output. Okay, if we try for some other Synoda get, we know that these would have clashed because they have the same length of last name, so they will put a collision. So ideally, in our case, when we have handled the collision using linear probing, then this should be present in the hash table, which we have got in the output. In our last video, when we saw that this was deleted since we did not handle collision. Okay, and here we see that gates, this would not have got inserted because we had the hash table of 5. So if we try to find gates over there, then let's try to get gates over there, and this should return null. So over here we see that it's a null over here. Okay, so this was the implementation for get and put in hash table using linear probing. Okay, please write any comment if you have any doubt about it. Thank you for watching the video. Please subscribe and like our video to encourage the work. Thank you.